First of all, thank you and our previous speaker for being so nice to allow us. We have a tight flight schedule, and well, at the end, things are always a little bit more complicated. Well, what I'm going to introduce is the activity of a research project. I mean, it's an innovation project, to be precise, in which we have been involved. It's the continuation of a previous effort we made some time ago, in which what we are, one of the aspects that I think, and is more important that we are addressing, is precisely the incorporation of the DevOps cycle in the telco environment. We don't have any problem about being a telco at all. We are, and among other things, and among other things, something that we are proud of is that precisely, and we insist that very much, is that precisely one of the main assets we have is precisely that we're running a network. We are running a physical network, and we have customers that use that physical networks and that physical network, and we are taking advantage to provide services on them. And what we are thinking is precisely about the possibility of expanding those services, making them better, automate them, and making them routing on them other services for the users. So basically, the results of 5G Tango. Well, so it's first is a reflection on something that I have heard a couple of people today is about that the all enthusiasm that everybody had about NFV some years ago has somehow faded. And well, this is this idea of the SDN and NFV in the post-hype area is from the project coordinator that is sitting over there. Is this guy that is laughing? So if you have anything to ask him, not me. It's, is the one who really knows and the one that will stay here while I go to catch my flights. The idea is that these ideas of this, that there was a big revolution coming, everything is going to change, there was a radical change in telco space, etc. Well, it's as usual, as many things, we were completely we were high on the hype, and we were, I was one of them, promising the complete revolution. But well, right now, what telcos are doing, and this is completely rational in economic terms, as you were showing during the graphics, is that we are following on the focusing on the low-hanging fruit. And the typical example is this idea of the VCPE or the universal CPE, which are the places in which it's clear that that virtualization will provide benefits immediately. And well, we have found, and this is something, it's curious because it's something that we started to talk very early in the process when we were standardizing the NFV movement, so to say. It was something that was clear very soon. It was about that the operationalization of the whole NFV was going to be a challenge, a very serious challenge. By that moment, we were naive, and we thought that it was more important to guarantee the interoperability with the existing infrastructures and the system management mechanisms, rather than radically changing everything. And to some extent, it's something that from time to time, I guess you know about the theory of Pareto. Pareto is an Italian economist that is formulated this idea that is during 20% of the time you achieve 80% of your goals, and then you have to dedicate 80% of your time to the 20%, the resting 20% of your goals. We're now suffering this. I mean, theoretically, we have everything in place. We know how to do it. We have orchestrators. We have the mechanism of doing so. But there are many fine-grained details that still we have to master to make the operationalization really active, including, among other things, heterogeneity, the dealing with existing elements that are not going to disappear at all, and for sure this idea of achieving zero-touch automation. We believe that one of the ways of achieving this is precisely by redefining the connection between vendor and operators. It's not that we are going to fill all telcos with developers that will develop everything. And this is very important because what we have to do is to adapt the DevOps processes to the real telco environment, which is something that if you think about it in the cloud world in which DevOps was coined, it was a single company process. The guys who are developing, the guys who are operating the services belong to the same company. They report to common managers, and they have common objectives. In this case, at least you have two parts. You have the vendor and the operator. In many cases, you have third or fourth parties intervening, and you need something that is a little bit more evolved and better adapted to the requirements of the sector. So we started analyzing it, and one of the basic things is that instead of going for something that originally was very much in the mindset of people dealing with NFV, that there was a function-oriented life cycle. Remember the BNFM, the BNF manager, and things like that. It's to address the whole problem from a service-oriented life cycle, looking at each service as a unit, and interacting with the service and letting the other components inside the service definition to take care of the individual functions. And the idea is to identify three basic aspects that were to be provided by let me say this, in the real DevOps scenario that you can apply in network operations that would interact, and that would interact more than anything through a mechanism of shared data, shared catalog in which services will be made available and will be collected for whatever the function, whether developing the service, validating it, or running and operating it actively. And the idea is that for each one of them, we have different steps or phases in the DevOps cycle. And for each one of them, we have an environment in which these steps will be taken. It's assumed that the developer, the service developer, the functions are supposed to come in from wherever they have to come. Service developer is using an SDK, a service development kit, that is important because it provides an integrated view of the other steps, and works in a local environment, and what is able is to install the service definition in this common catalog where whoever is making the qualification, the validation and verification of the service, whether it is internal to the operator, whether it is external to the operator, and is a third party, can use it, running it in a dedicated environment that somehow is similar to the final operational one, but that has much more knobs. Much more knobs and much more points to attach a probe to measure and to evaluate. Things that are not precisely highly efficient in operational environments can be deployed here precisely to enhance the measurement capabilities. So I forgot, in the production environment you have the service platform that corresponds to the service development kit, so it reflects what the selection that has been made by the developer and validated by the validation environment. So basically, the architecture is as I said, is precisely like this. We have a set of catalogs that are shared, and the communication basically the communication happens precisely model-oriented by uploading and downloading the models for the services from the common catalogs, and qualifying them when a new version is available, qualifying them as this is a new version that hasn't been validated yet, or qualifying them when you're running the verification has been performed. You can qualify it as verified, and in the case when you start running it, you can qualify even as running. So trust for a third a future deployment of the service can be assigned to a higher level. In any case, we have the different mechanisms for emulating the infrastructure, and this is important because one of the contributions that I am most proud of this project is precisely the infrastructure emulator that allows, and is a real emulator, and allows the developers to precisely make a complete, as complete as possible validation before they go into the formal. So basically, this is another view of the whole architecture, just identifying where you're doing you are helping the develop phase and where you're helping the operations phase. Important things here, let me say, is that this in despite of, for sure, looks much more complicated than the typical DevOps diagrams you see. Is about the almighty developers throwing pieces of code. But this is because we are talking of two things that are different. First is this difference between the service developer and the service operator. That they have different goals, different allegiances. And on the other hand, this is important, we are talking about an extremely delicate, highly dynamic environment. A network is something that is extremely complicated. Some time ago, I had the opportunity of reading a book that was claiming for something that they call internet science. Because internet science, their claim was that precisely the internet or any network that is of a size, that is enough, or that is big enough, has effects that are similar with what you get in a laser. You can get normal light, but when there is an alignment of the behaviors because of, in many cases, unpredictable causes, you get effects that are multiplied by, well, not multiplied, they escalate several orders of magnitude. And this is something very important when we are dealing with networks and we are thinking about implementing the other techniques that comes from a different discipline. And the idea is that precisely this part that in which you are able to make the test, make the validation of everything before and qualify it before the service is deployed. So in this respect, on the part of developing, the idea is to, well, there is an SDK, as I said before, that is intended to automate as much as possible all the process. So the service developer can focus on the service itself and not in the subtleties of the syntaxes and the attachment of points of presence, etc. It prepares everything, packages everything, and leaves the whole model ready for being consumed by the other parts. And this emulation, which is something that is a part of the SONATA software distribution, and this has been contributed to OSM, and it's part of OSM as well. Allows you to run a complete view of the infrastructure on which you plan to deploy the service in the future. This is how. But not just simply to illustrate how is a structure is as you can imagine. This is modern software. It's microservice oriented. It's everything. All these components are containers. They run in a small footprint. This is something that we are trying as well, is to try to address real operational environments in which you don't have infinite power and you cannot run several hundred thousands of virtual machines. It's microservice oriented. It's a container based, and what allows you is to go along the full path of all the different steps that you have to go since you create the project for the service definition up to the moment in which it's ready for being uploaded to the catalog. For verifying and validation, there is a separate environment that is basically, it has an environment that is similar to a normal orchestration environment and a normal infrastructure. With two other things is that the infrastructure is much more flexible at the price of being less efficient. And there are precisely mechanisms to run the different tests in the different phases. And in fact, we have defined so far two test platforms. One is using TTCN3, which is a standard way of specifying communication tests, and we have basically bash scripts if you feel like it's something that is more complicated. Something that is important here is that test is intended to be as model-based as possible. I would say that we have not achieved full model-based yet, but the idea is that precisely you are able to take in the service descriptor, execute the tests, have access to the external references, to test scripts, apply them, collect the results, and well, get a test report that can be incorporated at the model as well, so to help in further deployment. The idea is to address continuous testing, so you can put this in an almost fully automated loop. in the moment the developer makes the service available. And to close the loop, what we have is precisely the, a service platform. We have a Manos stack, we have mechanisms for monitoring, and mechanisms for SLA management and policy enforcement. And what is important, that is what Ricard is going to present after me, is precisely a mechanism for slice support. And let me say that is the first no-nonsense slice approach I have seen. That means that it's something that works, that is practical, that doesn't think too much about, all the possible concepts and the several zillions of slices and types that will be on the network. The idea has been to provide something that helps us in thinking about how slicing is, what slicing would imply for the network, and what comes from it. The curious thing is that, this loop is that, as I said before, we are mimicking in the validation environment, the operational environment. So the operational environment comes in these two flavors. And it's mediated by a piece of software that I like very much, that is a gatekeeper. Whenever I have made a presentation on this, I insist very much on this because it is very much related to my previous work in a former life. And the idea is that the gatekeeper takes control, and it's precisely the point for checkpointing whatever comes from the developers and is going to be deployed on top of the production infrastructure. The idea there is to verify that apart from the rules dealing with the policy and who can deploy what and who can put them, something that is important is about making basic sanity checks that would guarantee that the disruption in case of failure is going to be controlled. The orchestration of the service platform, because it's very important, it controls the access to the monitoring data. So each service can access the monitoring data that has been enabled to, and no more. And take into account that monitoring data can become extremely sensitive and can become one of the most valuable assets that we will be moving around in the network. And it keeps something that is important as well, that is an audit trail. So whenever something is broken, you know who took the step that is broken. In the previous session, in another room, we were talking about automation and the closed loops, etc. Having a proper trace of what's happened and some hints about why it happened is something that is essential if we want to go for real automation, because otherwise we won't be able of backtracing whatever happens in the whatever nasty happened in the or even is a happy which is the name serendipity. Could happen as well. Well, just this is just for being clear. 5G Tango is the name of the project. SONATA is the name of the software suite that provides this. Nothing to do with MEF. Just if any of you is thinking about this. In fact, this predates MEF, so it's something that we should go on and sue them because of the of the copyright. And well, basically, recently we launched version 4. Part of it, and this is something that is connected to this one, part of it has been contributed to OSM. And this is precisely what do we do in 5G Tango? It's a research project that is, and why are we using it if we are advocating for OSM, for example? Well, basically, because we are experimenting here, Telefónica, and this is Telefónica, is experimenting here with new paradigms that can be enabled by tools like OSM, but we want to play a little bit with and experiment before we put them in as part of the normal cycle. Second is because when I was mentioning operationalization is something that is very important, and it's precisely this idea of integrating Mano and the OSS, BSS, or whatever you call them, because here I have seen it's called service orchestrator instead of OSS, and provision portal or something like that instead of BSS, whatever. But this is the way in which you show your customers the services you're providing. As I said before, it's important that, let me say, this is the first no-nonsense slicing approach that I've seen. And, and this is something that is important as well, is that the connection between 5G Tango, the SONATA software suite, and OSM is very important for us because whenever something that is like the emulator I was mentioning before, like the work we are doing currently on slicing, etc., is going to be transferred to the mainstream OSM in the future. And this is a reminder of the basic facts. What it is a project funded by the European Union, 30 months, 17 partners. With these goals, I will try to go fast to finish on time. Basically, and well, these are what we believe are our key contributions is about the SDK, the concept of an SDK to facilitate service deployment and DevOps, the integration of the validation and verification, seeking for a completely automated loop for service development. The idea of a modular service platform, I was not in detail about this, but this is something that is extensible and would support much better precisely use cases, in general orchestrators, use cases related to particular slices with concrete requirements. And what is the goal of the talk, it was precisely about to illustrate how we are thinking about a methodology that allows to bring the DevOps into a real, and this is very important, a real telco environment. And as I said before, 40 seconds left, so not bad. Thank you.